In this video, I am on the balancing chemical equations PhET simulation, and I'm going to do a couple of examples in the game. Because level 1 is a little bit easier, I'm going to do one example from level 2 and one example from level 3. If you've used the other part of this simulation before, then you remember that in this simulation what we're essentially doing is changing the coefficients, the numbers out in front of the reactants and the numbers out in front of the products. So for example, if I add one water molecule on the left hand side, you can see the hydrogen and oxygen atoms. H2O, right? So there must be two hydrogen atoms there. Hydrogen must be those white dots that you see. And the larger red atom there must be the oxygen. And so right now, by adding that 1, increasing the coefficient there to 1, I automatically have two hydrogen atoms, 1, 2. And if you look on the right-hand side, if I add one of these, in this compound, HF, there's only one H. And there again, you see there's a white dot there that represents the hydrogen atom. And so right now, there are two hydrogen atoms on the left and only one hydrogen atom on the right. And so we say that the chemical equation is not balanced. And so in order to make it balanced, you need to add more hydrogen on the right. And so by adding one more of these, I see that now there's 1, 2 hydrogen atoms, and on the left-hand side I also have 1, 2 hydrogen atoms. So right now the hydrogens are balanced, but what you should notice is that this larger yellow atom here is fluorine. It's the F in this HF compound. And that larger yellow atom, I see there's two of those. So there's two fluorines right now on the right-hand side. And so if I go back on the left and I add one of these, it seems like everything should be balanced, right? I have two fluorines, two fluorines, two hydrogen atoms, but then I notice that there's an oxygen atom on the left. There is an oxygen atom that was part of the reactants, but I don't see it in the box for the products. And so I need to add oxygen on the right, and the only way to do that is by adding one of these OF2 molecules. And so once I've done that, I now have one oxygen on the right and one oxygen on the left. But in doing that, I have inadvertently added more fluorines, which was not my goal. But I have to balance the oxygens, and in doing that, I've made the fluorines become unbalanced. And so now I need to recount the fluorines again. I have 1, 2, 3, 4 of them, right? 4 yellow dots. And so now I only have 2 on the left, so I need to add 2 more. And when I add another F2 molecule, I now have 1, 2, 3, 4 on the left and 1, 2, 3, 4 on the right. So the yellow atoms, the fluorine atoms, are balanced. If I again check the oxygen atoms, there's one red atom on the left and one red atom on the right. And lastly, the hydrogen atoms, there's 1, 2 here, and there's 1, 2 here. And so what we've done is, by changing the coefficients, we balanced the chemical equation. And I know when the chemical equation is balanced if I count the number of each type of atom on the left and right side, and they add up to the same amounts. Okay? And so for this reaction, the coefficients have to be 2, 1, 1, 2. And in order for this reaction to occur, then the coefficients have to be exactly that. And so each time you go through one of these examples, you'll find that the coefficients will be a little bit different because each reaction is a little bit different. And so now we just need to press check. And apparently it was balanced because I got the little smiley face and it says +2. And so now what I'm going to do is I'll go back to the home screen and I'll click on Game. And we'll start over, and this time we'll go and do an example from level 3. Alright, now looking at this example, we're going to go through the same thing, but you'll see at the bottom we have a different reaction. And so one way you can start is by making everything just be 1. Because if you start in that way, it's okay, because if there weren't any of the reactants there, if there weren't any of the products there, then it wouldn't have been listed. So you at least know that if it's listed at the bottom, the coefficient should at least be 1. And most likely there's going to be a couple of them that need to be a higher number. And so starting with this, it looks like, again here I see some hydrogen atoms, these white dots. There's 2 of them on the left, 2 of them on the right, so that's good. The grayish atoms seem to be carbon, right? Capital letter C is carbon. And there's 2 of those on the left, but there's only 1 of them on the right. So I need to add another carbon on the right. Now there's 2 carbons on the left and 2 carbons on the right. And again, that red atom is oxygen. And right now there's 2 here on the left, and there's 1, 2, 3, 4, 5 on the right. And it might not be so obvious how we're going to balance 2 and 5, because every time I add more oxygen on the left, it's going to be in multiples of 2, because we have O2, which is a diatomic molecule. And so, for example, right now I have 4, and on the other side I have 5. So if I add another one, now I have 6. Now I have too much. And so I'm never going to be able to just make the left side have 5 oxygens. So I'm going to need to do something about that on the right-hand side. Like, for example, if I added another water molecule, I have 6 on the left, and I have 1, 2, 3, 4, 5, 6 on the right, because each water molecule has just 1 oxygen atom. And so now the red oxygen atoms are balanced. There's 6 and 6. But if I take a look at the hydrogen atoms now, on the right side I have 1, 2, 3, 4, and on the left side there's only 2. And so in order for there to be 4 hydrogens on both sides, I need to add 1 more of these molecules on the left. And now you can count them, right? 1, 2, 3, 4 on the left, and 1, 2, 3, 4 on the right. So the oxygen molecules are balanced, the hydrogen molecules are balanced. We just need to double check the carbons. On the left-hand side, there are 4 carbon atoms. And on the right-hand side, I only have 2. So it looks like, once again, we're going to have to kind of like mess this thing up a little bit in order to correct the carbons, and then we'll have to go back and correct the oxygens again. So I already have 4 carbons on the left, so I need 4 carbons on the right. And when I do that, now I've added a lot more oxygen, right? You can count 2, 4, 6, 8, 10 oxygens on the right-hand side. So I need 2, 4, 6, 8, 10 oxygens on the left-hand side. So now let's go through again and let's count up all the atoms and see if we've done this correctly. On the left-hand side, there's 1, 2, 3, 4 carbon atoms. On the right side, there's 1, 2, 3, 4 carbon atoms. On the left-hand side, there's 1, 2, 3, 4 hydrogen atoms. And on the right side, there's also 4 hydrogen atoms. On the left side, there's 2, 4, 6, 8, 10 oxygen atoms. And on the right side, there's 2, 4, 6, 8, 9, 10 oxygen atoms. So now that I've gone through and I've confirmed that all of the amounts of atoms on the left and right side are balanced, I know that what I'm seeing in the pictures here obey the law of conservation of mass, where there aren't any atoms disappearing or appearing out of nowhere, then the equation should be balanced. So once again I hit check, and it says that it's balanced. And so in order for this reaction to occur, these 2 molecules on the left have to combine in a 2:5 ratio, and when they do so, they produce carbon dioxide and water in a 4:2 ratio. Okay, so the goal here is that you should be able to now go through levels 1, 2, and 3 and do a pretty good job in trying to balance all of these.